Good evening, everyone. Welcome to the third day of AI in Education, Tools and Trends in Teaching, 6 days ATAL Online FDP. Now, it's time for our session 5. Yesterday, we had a wonderful session by Professor Manjubala Bisi ma'am, Assistant Professor NIT Warangal. Yesterday, we learned explainable AI for ML. We have gone into some technicalities, and at the end, we were taught how to apply them to the educational scenario. It was a wonderful lecture, ma'am. Thank you for that. And again, today we are excited to have one more lecture on the similar topics explained by AI. Uh, I welcome you, ma'am, Manjubala Bisi, ma'am, and I hand over the session to you, ma'am. Please.
Thank you, sir. Thank you, sir. Am I audible, sir?
Yes, ma'am, you're audible, ma'am.
Okay. Yeah, a very good afternoon to all the participants again. So I think this is the third day of this ATAL Online FDP on, right, this AI in education. So yesterday we have, right, because I don't know about the backgrounds of the participants, and so I went to the technical part, right. So today I'm planning, right, I planned for to give this explainable AI case study. So I will give that case study, but before going to that case study, I will tell what are the things we can automate in the education by using the different educational, the different AI based techniques, right. So let me share my screen. I hope my PPT is visible, sir. Can anybody confirm whether the PPT is visible?
Yes, ma'am, it's visible, ma'am.
Okay. So this is the topic, right? That is the explainable AI case study. So one case study in the explainable AI related to this software reliability. So initially I thought to focus technically, but I will not focus technically because participants are from diverse backgrounds, right? So first I will see how this AI in education, what are the things that we can automate in the educational system by using the AI, right? Then at the end, I will show you one case study in this software reliability because at the end we have to develop the software, right? We want to design a AI-based education system. That means we want to develop a software for that and how to assess the reliability of that software. For that, I will show you one case study by using the explainable AI, right? I think it will help the participants from diverse backgrounds, right? So yesterday we have seen the explainable AI framework in the education system, where we have seen who are the different stakeholders in the educational system, right? And what type of tasks we can automate by using this AI-based techniques, right? So if you see the evaluation of artificial intelligence in the education, so previously it was the traditional teaching system we used to, right? There is a blackboard, we want to use the chalk, right? That is the blackboard chalk teaching style was there, traditional teaching. Now the evaluation is that this is the we are using the different technology in the education, that is the ed tech we can consider. That means the digital things we are incorporating in the classroom, like we are using the ppts, we are using the blended learning, right? So many things we are using in the educational technology. Now it's time for this AI powered learning, right? So how AI can be powered in the learning system of the education, right? So there are different statistics on this AI adaptation in education. If you see the literature, AI in education, so generally the different people from the researchers from the humanity background, they have done different statistics, right? Whether this AI, right, AI adoption in education, whether the stakeholders, right, how much they are liking this AI adoption in education, right? So different country, I have come across 2 3 papers. So till now I have not found any paper related to the Indian context. So mainly those papers, they are related to analyze the AI adaptation in education in the China, right? So they have taken the right, they have found some questionnaires, they have taken the data from different people, different stakeholders of the education system, and how the AI adaptation in education, it is helping them, right? Different stakeholders, they have also some analysis they have done. right? So if you see what are the key technology in the education, generally we have to use the machine learning techniques, right? That we have to incorporate in the education. We have to go for the language, natural language processing. You have to go for the computer vision, right? Then we have to go for the chatbots and the virtual assistants, which will replace the physical or the presence of the teacher in the classroom, right? So these are the broad key or the AI technology. This you can use in the education, right? AI based education system, right? So our focus is now whether we are going to use a existing AI based education system or we are going to design AI based education system. So these are two different perspectives, right? So and in order to implement a AI based education system, it will be very costly, right? So if you are used people, everybody, right, nowadays many people, many students, many people, they are using different AI based systems to do something, right? Suppose we want to automate our workload, right? Whatever the administration they are doing in the institute, we have a automation process, right? It will automatically generate the grade set, it will generate automatically feedback to the students depending upon the grades they got, right? So we are using those things, right? Still, in which direction we can, right, how to integrate this AI technology in the education, that is the main focus. So the main focus is how we are going to develop a AI based education system, right? So for that we have to understand the key technologies, right, so that we can use this technology to develop a AI based education system. So generally, in the if you see the applications of AI in the education, right, it will help generally. This is the intelligent tutoring systems. You can design the intelligent tutoring system. So there exist some intelligent tutoring systems, right? But right, the institutes they may not allow to use these intelligent systems in the institute, right? Because it may be due to the cost, right? It will be highly cost, right? So that they cannot accommodate, right? So there are some intelligent tutoring systems. There are some adaptive learning platforms. So the intelligent tutoring system, it will help the teachers, right? Teachers in the education. So here the stakeholders are the teachers. In the adaptive learning platforms, our students are the stakeholders here, right? Students will use this AI-based system. Virtual classroom, AI assistant, this will help also our students. Personalized learning path, it will help the students as well as if the teachers they are trying to learn some new thing, it will also help them to learn, right, new things. And the automatic administrative task, it will help the, right, the higher authorities or the administration of an educational system. So generally this is the broad area where the AI can be brought into the education system. So let us see what each of the system is doing and what are the different tools already available, right? Different institutes they are using, right? So system. So this ITS system, generally, as I told, the teachers are the stakeholders for the system. So it will provide the guidance and the feedback to the learners, right? Similar to a human tutor, right? So the intelligent tutoring system, it will help also the students, right? Suppose teacher want to learn something, so they can use the intelligent tutoring system. Students want to learn something, they can also use this intelligent tutoring system. So it will both help the student as well as the teacher. So what will happen in the ITS system? They will, the student or the teacher who are the stakeholders, generally they will adopt the learning content present in this ITS system, right? And this will, the pace, right, according to the learning content and the pace, as per the student's strength, weakness and the progress, they can adopt the different learning content present in the ITS, right? So generally they use the, as I told, the AI techniques like NLP, natural language processing, machine learning to in order to do the interaction, right, or the one-to-one instruction by the teacher. So if you provide this ITS, generally it will offer instant feedback and some good exercises to the learners, so that it will, how it will help? It will help to enhance the engagement of the students, right? It will help to improve the learning outcome. As you know, there are different outcomes, learning outcome designed for each subject in the higher education system, right? And it will reduce the burden on the teachers, right? So due to these things, because how we are giving manually, how we are giving feedback to our students, whenever some exam is there or whenever we are giving some assignment to the students. They are submitting assignments, they are writing the exam, or we are asking some questions in the class. Depending upon that, we are giving some some feedback to the students. So that process can be reduced, right, by using this intelligent tutoring system, by adopting in the AI based education. So there are different intelligent tutoring systems. So Math IA, this is one AI powered tutoring system. Generally, this AI based system, this is designed to teach the mathematics, the subject mathematics, right? So who the participants who are from mathematics background, you please check this one Math IA, right? Generally, all the this AI powered systems, these are now free, right? Free cost, right? So you have to pay something, then you can use these systems. What it will do, this Math IA, it will adapt to the each learner's skill level and provides the step-by-step guidance to learn the mathematics subject, right? So the system, it will give the real-time hints, like whenever we are teaching mathematics to the students, we are giving some real-time hints. We are giving also some feedback. Suppose so they are adopting some process or the methodology which will not generate or which will not lead to the final answer. So there also we are interrupting them, and you are asking them, you please don't follow this method, you follow that method, then you may reach to the solution of the given problem, right? And we are providing explanations to the students, like a human tutor, whatever you are doing. This Math IA, this is also giving the same thing, right? It is helping the students to learn only the mathematics subjects, right? So the teachers generally, they will for the student side, they are getting these things, right? Real-time hints, feedback from the system, and the explanation by the system regarding the feedback, right? So how it will help the teachers? Because I told this is also, right, it will help also the stakeholder, that is the teachers, right? So teachers, they will receive the analytics dashboard here, right? So what it will show? It will show how the students are progressing, right? What are the misconceptions of the students regarding this topic or the subject, and in which area they have to move, right? They have to do hard work, or they need the intervention, so the feedback will be better, right? So these are the things that the dashboard is given to the teacher by this ITS system, right? And there is another ITS intelligent tutoring system, that is the Duolingo. So generally this is related to the CSC background, right? So it uses the intelligent tutoring principles. So intelligent tutoring principle means how it will help the students by using these things, how it will help the teachers by providing a analytics dashboard, right? That will show these three things: progress, misconception, and the way in which areas they have to improve, right? So this Duolingo, this is right, also using the ITS principles. So it will personalize the language learning through your adaptive exercises and the instant feedback, right? Like we are writing some online exam, right? And we are suppose MCQ, maybe you all, if you have written some MCQ test online, right? So whenever you are opting a solution, if that solution is correct, then it will give some, okay, congratulations, your answer is correct. Or if suppose you have clicked a wrong choice, right? So it may show that, sorry, your answer is wrong, right? Or sometimes some systems also, they will provide the feedback, like, suppose the answer is in the digits or the integer format, right? You are nearer to the correct answer, like that. Some feedback it will give, right? So this is the Duolingo. Duolingo is also one intelligent tutoring system, which is that is a AI based education, that we can, that is the tool we can use, right, for this purpose, right? The students can use and the teachers can use, but depending upon the availability of the system, right? So if the system is not there, so we have to design the system, right? So in order to design this system, we have to know the technical things, right? Otherwise we cannot design. If somebody is designing by free of cost, you will not give the software, right? So we have to pay something, then we have to use. Of course, there are many free softwares or the free AI based tools, those we can use in the education, right? So the first thing we have seen, this is the intelligent tutoring system. Next is the adaptive learning platform, or the personalized learning path. You can combine into a single group also. So in the adaptive learning platform, generally it will use the AI, artificial intelligence, right? So adjust the learning materials dynamically, based on the student's performance, behavior, and the preferences. Like that, what we are doing in the class, right? Suppose we have taught a concept to the students. They are so whatever material we have given them, there are some students they are unable to follow those things. So what we are trying? We are trying to right provide some extra material, learning material to those students so that they can perform better, right? So same thing, the adaptive learning platform also they will do, right? So they will use this AI to adjust the learning materials, but it is dynamically. So how it will change the learning materials depending upon the student's performance, behavior, and the preferences. So these things the system has to monitor, right? So how the system will monitor the student performance? Maybe the system will ask some questions to the students depending upon whatever learning material it gave. If the student is unable to answer those questions from that material, so it will try to change the learning material dynamically, right? Next, it will also provide the personalized pathways so that the learners can progress at their own pace, right? Because some students they will learn quickly. Some students, right, they are very slow learners, right? So it will help this adaptive learning platform. It will help right the students of different pace so that as per their pace, own pace, they can use that system. So depending upon that, because it will provide the learning material depending upon the pace of the students also, right? So generally, these adaptive learning platforms, it will analyze the real data, right? So identify the knowledge gaps and deliver the targeted exercises or the resources to the student. So everything is related to the data, right? If you are talking about the AI in education, it needs the historical data, right? So it has to, the system has to be loaded with the historical data or the real-time data. Then the AI-based algorithms will analyze those things, right? So there are some algorithms will analyze what is the performance of the students, or they will some algorithms they will predict some features or the attribute values the system is asking to the students. Then depending upon the feature value, the system is trying to predict, right? What is the student performance, whether the student performance is good, whether this is average or this is bad. Again, that became a classification problem, right? So that problem, that predictions predicting the student performance, again it became a classification problem. So we are having different classifiers in the ML, right? Machine learning models, which comes under your AI, right? Again, we have to go to those classifiers which will analyze the data, whatever your data is given to the AI-based system, and it will apply or it will run those algorithms to do this prediction, right? So that is happening inside. But we are using outside. We don't know about the internally what is happening, right? But we have to know what is going on inside that system, right? So generally, the adaptive learning platform, it will tailor or it will help to the individual needs, right? It will improve the student engagement also, student retention also it will reduce, and the overall outcome of the educational system, it may become good by using the adaptive learning platforms. That's why, right, the AI based educational system, whether the students are liking or the students are not liking. So there are different statistics, right? So you have to do the statistics, then we have to allow the students to go for this AI-based system, right? And there are some adaptive learning platforms already available. If you come to this example of this adaptive learning platforms, and maybe you may have heard about this Coursera, right? So this is a AI-powered recommendation system. It will suggest the course sequence, right? Personalized course sequences. Suppose because I want to know the algorithm and the analysis subject, so it will give that you should know the data structure before reading this algorithm and analysis. It will give suggestion to the students or the learners that you should know the data structure before knowing the algorithm analysis, right? Like you should know the AI, you should know the ML before going to the explainable AI. So these are the what are the prerequisites. If you see your curriculum, whenever you are developing the right your academic syllabus we are preparing, and there is a prerequisite we are remembering, right? What is the course code, or what is the how many credits we are giving to that subject, and what is the prerequisite from that subject, right? Similar like your algorithm analysis, we need the data structure, right? Like that. So this Coursera, this is the example of the adaptive learning platform, right? So it will use the learner's performance and the interest to adapt the content delivery. Depending upon that, it will deliver the contents. So there exists another adaptive learning platform also. You can write that is the Smart Sparrow, right? So generally it will provide the adaptive simulations and the interactive lessons in the computer science topics, right? So it will adjust the problem difficulty and hints based on the student responses, right? So everything, our motto is that the how the systems, it will help the students, right, as per their own pace, so that they will be comfortable for using this AI based system, right? So this is the second one. So we have discussed about the intelligent tutorial system. Second one is the adaptive learning platforms. The third one is virtual classrooms and the AI assistants. These are also so you know the virtual classroom, right? And who are your AI assistant? Already all of you were using these things, right? So virtual classrooms, what are the? These are the powered by the AI, right? These are the interactive, real-time learning experiences beyond geographical boundaries, right? So no need to come to the classroom here, right? Because the name itself is virtual classroom. So this is independent of the geographical boundary, right? Anywhere, anytime you can sit and you can use those systems for learning purpose, right? And what the AI assistants it will do? Generally, the AI assistants it will support the teachers. So this will the virtual classrooms it will help the teacher as well as the students, whereas the AI assistants it will support the teachers by automating some tasks such as how to schedule the class, how to do the attendance tracking, how to do grading, how to answer the student queries daily basis. So these are the things the teacher is doing, right? So instead of manually the teacher has to do these things. So the AI assistant it will help the teachers to do these things, right? But for that we have to write everything. We have to write algorithm, right? The scheduling, I want to do the scheduling, right? So there some optimization algorithm you have to apply so that the number of conflicts should be minimum, right? So those are the things we have to integrate here. And this virtual classrooms, right, and the AI assistants, generally this will right, it will provide the personalized learning support, reminders to the students, instant feedback to the students, and it will enhance the engagement also, right? So if you mix the class, this virtual classroom and the AI assistant, generally it will create a flexible and accessible and the efficient digital learning environment, right? Because we are not coming physically to the classroom, we are not meeting the teacher. So this looks like a digital learning environment where you can use, right? Where it will help the stakeholders of the education systems. So this example of the virtual classroom, all of you we are using the Google Classroom, right? So Google Classroom, what we are doing? We are right. We are having a virtual space for classes, assignments, discussions, anything we are posting on the Google Classroom. Students are able to access those things. If students want to ask anything to the teacher, they can. They are posting in that Google Classroom, right? So here, in the Google Classroom, how these AI tools can be integrated. So maybe you were aware of these plagiarism checker, right? So there are some AI integrators like you can check the plagiarism. Suppose we have given one assignment to the student, and the students generally what they will do, they will try to copy from each other, right? So we cannot give right 10 marks to all the. Suppose the assignment is for 10 marks, and the same things the students have copied, right? So 10 marks we cannot give to all the students. So we have some plagiarism checker. So plagiarism checker, it will check, right, from which portion or from who is copied from, right? The content of the two students' assignment answers are same or not, right? And again, we have to that identifying who has copied from whom. Again, that is again a problem, right? So those things also plagiarism checker that can be integrated with the Google Classroom. Auto grading, right? That can be integrated in the Google Classroom. Smart suggestion, right? Smart suggestion depending upon the student query. If you integrate the AI tools into the Google Classroom, some smart suggestion automatically, right? No need, we have to open the Google Classroom and we have to answer the queries, right? So some smart suggestion also it can, this virtual classroom or the Google Classroom can give if we are integrating this AI tools, right? Which will make the teaching efficient. And if you have that, right, Microsoft Teams for education is there, right? Generally, it will support the live lecturers, right? This FDP, this is supported by your Microsoft team also it is doing, right? The breakout rooms. So these are all the things available in the Microsoft team. maybe during the COVID time, all we have explored all these virtual classrooms, right? And we are experienced with these virtual classrooms during the COVID time. And the collaborative coding sessions for CAC, suppose we are having the overleaf you are using, right? Overleaf for the preparing the technical content, overleaf you can share, right? Those things. Collaborative coding sessions, if you are using everything, right? In the Google also this facility is there. Google Colab is there. You are also collaborating the coding session in the Google Colab, right? So those are all the things we are getting from this virtual classroom that is available in the Microsoft Teams. So generally the AI features, it will include the real-time transcription, right? Smart scheduling and the attendance tracking. Attendance also this Microsoft team, right? Nobody is taking your attendance manually in this FDP, right? So the Microsoft team, it will automatically generate the attendance for the participants. That attendance list, right? The coordinators, they have to submit to the ATAL, right? So similarly, there is a facility in the Google Meet is there also. Google Meet also it will automatically record the attendance, right? So all these things are we are some of the things we are using because those are we are free, right? Or the cost is very less. Institute is able to provide us those systems we are using, right? But you can design the same system, some similar type of systems by right by knowing the technical details of the key components of the technology involved in the AI in education, right? So let us come to the AI assistant. So we have seen the Google Classroom, right? Google Classroom and the Microsoft Teams. These are coming under your virtual classroom, right? And second one, I think in this there is a AI assistant, right? So AI assistant, what it is doing? I think the Chat GPT everybody is using, right? Chat GPT is the AI assistant, right? Or co-pilot as AI tutor. So this acts as a personalized assistant to explain coding concept, whatever you are asking, whatever, right? Whatever you are asking to the Chat GPT, right? It is giving some content to you, right? Instantly it is answering the student questions, right? It is also giving. Or the co-pilot as AI tutor. And there is a AI assistant that is the IBM Watson tutor. It will also provide the subject specific guidance and answers, right? Which will personalize the learning and generally in the technical subjects, right? So these are all the some of the things available already you were using, those were available to you, right? The next application of AI in education is that is the personalized learning path. So this is similar to your adaptive learning system, right? You have to choose a particular learning path by which you can reach to your objective, right? So that path, learning path has to be given by the AI based system, right? So generally the personalized learning path, it will use the AI, right, in the educational journey depending upon the learner's skill, interest, and problem. Similar to your adaptive learning system, right? Own pace, own areas, sorry, own pace, own areas where they need the improvement. But the learning path, it will be adapted dynamically, right? Because it will provide the different resources. It will ask different types of problems by giving different exercises to the students, and it will do assessment for the students for this particular exercises, right? So that the learning outcome of the students has to be maximized. So depending upon that, the learning path will be changed. Again, if you see this third thing, this is a optimization problem, right? Our target is to maximize the learning outcomes. Our inputs are the different resources, different exercises, and the assessment of these exercises. So if you provide this data to the AI-based system, it will run some optimization algorithm so that it will maximize the learning outcome, right? So if you align this personalized learning path, right, with the individual goal, it will increase the motivation, right, engagement of the students and the long-term retention of the students, right? So this is also one of the major applications of AI in education. So there are right, some examples also, right? Examples of personalized learning path. Coursera, already I have shown you in the adaptive learning process, right? The EDX, it is there. So these are the AI-based recommendation system, right? So AI recommendation system means the learners, they will get generally the personalized course sequence based on their knowledge, performance, and the career goals. So these are the questions the system is going to ask to the learners. Depending upon the answers given by the students, it will provide a learning path to the students, right? Suppose I am giving one CSE student, right? Because I am related to CSE, right? I belong to the CSE, so all the examples I will give from the CSE, right? Suppose one of our CSE student is interested to learn AI, right? So what the Coursera, it will give the suggestion, or what is the learning path it will provide? It will give you learn first, you learn the Python basics, right? Then you learn data structures. Then you learn the machine learning. Then you learn the deep learning. Then it will help you to right, to learn about the subject AI, right? That means these are all the prerequisites, right? These are the requirements before you want to learn the AI based systems. You have to learn everything, right? Then only, so I'm telling from the design perspective only. Then only you can know all the technical things you can apply. So there are many Python basis you can use, that is a coding platform, that language you can use. Data structures you can use, which data structure is applicable for which problem. What is the machine learning algorithm you have to follow? If the problem you are unable to solve by using the machine learning, the data is very right large, or the big data, a large amount of data is there, whether the deep learning models can help to solve the problem, right? So all those things are required, right, to learn the AI. Or if some student wants to expert in AI, so he has to know all these things. So this path, learning path, right? Who will give this learning path? Generally, this will give this Coursera, the EDX system. So this is the example of your personalized learning path. Now, most of the, I think most of the participants, maybe you know about the CAN Academy, right? So it uses the mastery-based progression, right? Where learners move to the next topic only after demonstrating understanding the current topic, right? So it can also provide a dashboard to the students, which will show what are the strengths of the students and in which area the student need to improve, right? So these are the things if you provide, right, to the students, right, it will help in the personalized learning, right? So Duolingo already I told, this is also comes under your personalized learning path, and the adaptive also it's come under. So this only apply to the CSE background, right? So it will dynamically adjust the difficulty lessons depending upon their user mistakes and whatever error they are doing. Right? Similar, as I told, this is the similar to the adaptive techniques used in the previous, but the adaptive techniques, or some the coding practice platform also you can use those things. Right? So we have discussed the intelligent tutoring system. We have seen the adaptive learning system. Now we have seen the personalized learning system. That what is that virtual classroom and the AI assistants, right? And the last application is right. There are many more applications, but I have showing the major applications of the AI in the education system, right? Automating the administrative task, right? How to automate the administrative task? So AI, right? Everything you want to automate, right? That comes under your AI, right? So how to help the administrative people to automate their task? That is also again one of the application in the AI in education. So there the stakeholders are your administrative people. It may help, right, in the academic administration, or it may help in the non-academic administration also, right? So here I have reported only the academic administration task. So automated grading and the assessment. If you are having, your institute is having a system automatic administrative task for which will perform this automatic grading and the assessment, right? So everything will be now automated, right? So manually you no need to do the grading, no need to do the assessment. Attendance and the classroom management, right? Scheduling and the timetable, student records and the data management, communication support, right? So if you come to the automated grading and the assessment, right? Generally, right, we are having the grading. How will you do the automatic grading and the assessment? Many of you were conducting the MCQs, right? Objective test. So there are some AI tools which will grade the objective test, MCQs or quizzes instantly, right? So we are using the Google form. Sometimes we are sending the creating a Google form as a quiz. We are providing, suppose the MCQ question is MCQ, we are providing what is the question, what are the options, and we are providing the answer key also, so that it will do the assessment also, right? So MCQ, short answer questions, long answer questions, those things we are doing, right? Generally, the objective test for the MCQs, right? It will help, or the one word answer automatic grading and assessment will be helpful in the Google form, right? And if you know that we have used during the COVID in NIT Warangal, we have used our Moodle server, that is the learning management system. So we are having our own learning management system where the system, it will automatically grade the students. Only we have to, right? We have to provide the questions to the LMS. So we'll give that link. Students will write that exam, and when the students' exam is over, automatically it will generate the assessment of the students. So right, we are using from the NIT Warangal, we are having this LMS for automatic grading and the assessment, right? So there are great scope, Turnitin, those things are also there. This will help in your AI assisted grading also, right? And coming to the attendance and the classroom management, so biometric devices, now biometric devices, many institutions they are using, right? Or you are using the facial recognition system, smart ID scanning system. These are some of the things which will take the attendance automatically. Then it will manage the classroom attendance, right? And that attendance after taking the biometric device or the facial recognition, that can be integrated to the LMS, or if you are having any automation system in your institute, right? So in NIT Warangal, we are having our automation system, that is the NIT, right? NITW automation system, NITWS. So by which, right, every student can log into the system, all the faculties can log into the system, all the stakeholders related to the NIT Warangal, they can log into the system, right? And all the data you will get here, right? But till now that is not right. Some of the algorithms are implemented, but everything it is not giving, right? Some of the components right we have done in the NIT Warangal automation system, right? Timetabling. So generally you can integrate these AI tools to create the optimized schedule, right? It may be for classes, it may be for your examination, it may be the room's allocation to the timetable, right? So for that again you have to run some optimization algorithm behind, right? Which will try to minimize the number of conflicts, right? And coming to the student record and the data management, right? So generally the AI chatbots, right? You can use the AI chatbots, and the system, it will manage the student records, right? So whatever the admission fee, transcripts, everything it will manage. So there are some predictive analytics track, right? Where the student performance can be also, it can be predicted, right? And we can update the records of the student also, right? And the communication, coming to the communication and the support, right? So generally there are some AI powered chatbots or virtual assistants, right? Which will handle your frequently asked questions. Suppose you are asking some questions to the system. So it will say, what is the exam date? What is the deadline for filling the forms? What is the deadline for submitting the registration documents? What is the deadline for doing the subject registration in this automation system? What is the course information, what is the current semester, what type of courses is being offered for the first year students, CSE first year, first sem students, right? So this communication and the support, generally you can empower the AI by using the chatbots and the virtual assistants. So it will help the students to do some works, the academic works in the system, right? So generally I told the grade score. This is also AI assisted grading system. You can the IBM Watson and the chatbot, ChatGPT bots are there, which can answer the student and the parent queries related to this communication and the support. Right. So these are the some of the works, or you can automate the administrative work by enabling AI into the system. Right. So as I told, the AI in scheduling and the timetable, you can optimize the class scheduling, you can optimize the exam time scheduling, right? So exam time scheduling means, suppose there is an exam section which is doing everything in the institute, right, and the education system. So in the exam time scheduling, what the AI has to do, so you have to design a AI based system which will create the exam schedules, and what is the objective, it will minimize the student classes, right? So it will minimize the student classes among different years. That means two exams on the same day, it should not happen, right? So those are the constraints we have to give in to the AI based system. It will run some optimization algorithm, and it will provide the optimal exam timetable to the institute, right? So adaptive rescheduling also you can do by enabling AI in the system. Suppose some last minute we are handling some examination, and the last minute we want to change something in the exam schedule. Suppose some faculty is on leave, some holiday, right? Due to heavy rain, suppose the Telangana government declared some holiday instantly. Some resources unavailability. Suppose I have, right? Suppose the resource is not available at this particular time. Invigilator is not available at that particular time. Question paper is not available due to unavoidable circumstances. So in that scenario, how your system will do the adaptive residue, right? That is also one of the application of the AI in education, right? And the last one is your data-driven optimization. So as I know, the AI means your data. We are talking about data only. If we are having the data, then only we can apply the AI models, right? AI models, machine learning models to solve some problems. So data-driven optimization also you can do. So generally it will use the historical data, right? That means what is the enrollment trends of the students in the institute, what are the peak class times, what are the student preferences, whether the student want to write exam in the morning, whether the students want to write exam in the afternoon. That also matters a lot, right? So those information it will collect from the stakeholders. As per that, it will do some optimization, right? Generally, also the data-driven optimization, it will predict some future demands, and it will also suggest some optimal time slots to the students, right? So there are some AI-based, right, tools are there. What is the Opta Planner? This is the open source, right? So because we are not using these tools, because in the NIT Varangal, right, still our exam section is handling everything. Manually, they are doing these things, right? The AI based scheduling is it, because this is open source, you can go through it. And we are using the Moodle platform, but AI powered Moodle platform till now that is not there in NIT Varangal, right? But there are some AI powered LMS. If your institute is ready to buy, purchase those AI powered LMS, they can buy, and you can use those AI powered LMS to solve different tasks related to your education system, right? So these are some of the applications where we can apply the AI in the education system, right? Now, coming to the role of explainable AI in the education, yesterday also we have seen. So it should be as the AI-based education system, it is giving some recommendation to the students. It is giving some recommendation to the teachers, because it is providing, it is dynamically changing the content. It is learning content. It is dynamically providing a path, learning path, right? So what is the transparency in that decision given by your AI-based system, right? So for that, your explainable AI comes into the feature, right? So yesterday I told you about what is the use of the explainable AI. Now you refer to the explainable AI question bank, and what are the questions required for your education system, right? You try to answer those questions by using some explainable AI tools, right? So that should be transparency in the learning recommendations, right? It should be fair and biased. That is a free during the assessment, right? It will support the teacher. It will support right for the decision making by the administrative people. It will help in the student engagement and the trust about the education system. Suppose your institute is having a AI based system which will automatically grade the students, right? So what input it is getting? Suppose it is getting some students, some information it is asking to the students. The student is filling those information, or it is asking some information to the teachers, right? So some, that means some attribute or the some feature value it is asking. So those values it is given to this real time data to the AI based education system, right? Now your AI based system, either it is giving some recommendation or it is predicting something regarding the students, and that is the grading. If we are talking about the grading, it is grading. Suppose you see now the students, suppose two students, they are providing the same information to the system, but their grading is different, right? So whether the two students will trust the output of the model? No, right? So that should be, it should be fair assessment, and the bias assessment will be there. That means for the same input, it should not give two different type of explanations. Again, the teacher is giving the same information to the AI-based system. Again, it is giving different recommendation or different prediction regarding a situation. again the teacher will not trust the system, right? So for that, right, we have to bring this explainable AI into the picture, right? Which will, right, yesterday we have discussed that fair, accountability, those things, the transparency part. There are three things: fair, it should be accountable, it should be transparency, right? So transparency meaning, you know, fair you mean, accountability means this system should be responsible why it is giving the this judgment or this prediction or this grading to the students. Not only this will provide the grade, but it will give some justification to the grade so that the students or the stakeholders who are using this AI based system, they will trust the system, right? So this is the role of the explainable AI in education. Now I will come back to the, right, how this explainable AI, right, explainability of AI you can assess. So I will show you a case study. So initially I thought to give with respect to the software reliability part. Okay. So I will show you one data set, I will show you, and what type of explanation you can generate, right, by using the output of the machine learning model, right? So generally our target, suppose if we are concentrating on, we are going to design a AI based education system. Suppose it will, suppose you are going to develop a software. Generally this is a software, right? System means software. So it will automatically grade the students. Now, what are the features or the what are the inputs you required either from the students, because from the student information you cannot grade the students, right? So you want some information from the teachers. So the teacher is going to provide this information to the software, right? Now these are the inputs to the software. Now inside this you have to use some AI enabled algorithm, and depending upon that it will generate a grade to the students, right? So that is the purpose. Now what is this? This is the, so system means we are talking about the software. And what is the reliability now? Reliability means the probability of failure free operation, right? So at a particular instant of time or a particular period of time, right, what is the probability that the software will work without failure? So that is the software reliability, right? So generally in the software reliability, there are different parameters. So as we are talking about the probability, generally this will value will be in the range 0 to 1. Reliability value will be in the range 0 to 1. But in order to represent the reliability in the probability term, we want the failure data. So how many times the software is failing? So you have to test the software. There are different testing methods by which you can generate the test cases. The software will be tested, and some of the test cases the software may fail. Some of the test cases the software may pass. So those failure data is required to represent the software reliability in the range 0 to 1. So honestly, if you see, nobody is going to give their failure data for their developed software. So you will not get any real-time data, right? That's why the researchers, they are trying to predict the reliability of the software by using other parameters, right? So we don't want the failure data in that scenario. That means after testing phase of the development of the software only we can do that one, right? Now before testing phase, whatever information we are having, we'll use those information to do that one, right? So that is the basic concept of the software reliability. So these are the two widely used parameters by which we can access whether the software is reliable. So we can qualify, right? We cannot quantify the software reliability here. So by solving this problem, whether we are able to generate a reliable, we want to deliver a reliable software, or we are not able to deliver a right, highly reliable or the poor reliable software, right? So generally the first one is software fault prone module prediction. Second one is the software development effort prediction. So software fault prone module prediction means, so you are designing this system, right? So this is not a single module. This consists of number of modules. Say 10 modules are there in this software, module 1 to module 10, right? So we are having 10 modules here, M1 to M10, right? So software fault prone module prediction means we are going to identify out of these 10 modules, which modules are faulty modules, right? Then only we have to focus on these faulty modules, and whatever testing resources, generally we have the limited testing resources, right? We cannot test a software for the indefinite period of time. right? So within that limited time period, we have to test the software, and we have to so that what is the reliability of that software, right? So what we'll do, we'll try to um, divide these modules or classify these modules into two categories: fault prone module, non fault prone, and faulty module, not faulty module. Again, this became a classification problem. So binary classification, right? So you know what are the classifiers present for us to solve the binary classification problem, right? So that case study I will show. I will show with respect to the explainable AI only, how, what type of plots or what type of explanations you can generate from the output of the machine learning model. So that is the target. Now the second problem is software development effort prediction. So now your institute is going to develop the software which will automatically grade the students by using this information, right? So how much effort is required to develop the software, your institute has to estimate initially, right? Depending upon that, it will plan. Similar same thing happens whenever you are designing a software in the software industry, right? That's why you are estimating that 10 developers or 10 programmers are required to develop the software. So how they are getting that 10, right? So if you do the overestimation, we are estimating the effort required to develop the software. If you do the overestimation, right, you have to pay more, because budget is also one of the constraints to develop the software, right? And if you are doing the underestimation, suppose actually more programmers are required, but you are predicting that only two programmers you will give to develop the software. So in that scenario, your time is a constraint. Even if you are paying less salary to the programmer, because two programmers are there, so you are paying less amount, right? Okay. So if you are doing the underestimation, so it will take more time to develop the software, right? So these are the things indirectly it will impact on the reliability of the software, right? So the same thing whenever you are going to design a software related to the education system. So these are the parameters you can assess by which you can, right, you can conclude that whether this is a reliable software or this is not a reliable software. So these are the some of the, suppose the first parameter I will show you. This is the software fault prone module prediction. Generally, these are the attributes of the metric name, metrics which are required for predicting whether a module is faulty or not faulty. So what will be there in the module? LOC, how many lines count of code is there? These are all the technical terms related to software only, right? What is the cyclomatic complexity? What is the essential complexity? Design complexity? How many operators, total operators, operands are there? What is the volume? What is the program length? What is the difficulty level of the program? What is the intelligence level of the program? How much effort, Halstead effort? What is the Halstead value? Time estimator, line count, unique operand, total operand. What is the branch count of the flow, right? So if you have any knowledge about the software, you can understand. These are some of the features, right? Similarly, for your educational system, for the software you want to develop, you identify what are the attributes required to grade a student, right? What are the information you want, your system want to grade the student. You collect those information, because everything is dependent, AI based means everything is dependent on the historical data. You have to generate the data, or you have to take the data from the repository, right? So from the exam session, you can take some information also. So if these are the attributes, names of the feature information you are collecting, so how from these features you are going to predict whether a given module is faulty or not faulty. So we have some historical database. We'll collect some data where, suppose we are having 1,000 modules are there in the software. Each module 1 to module 1,000, these informations are given in our data set, right? So if you are using the historical data, so whether the module is faulty or not faulty, that is also given, because we are talking about the supervised one, right? Module 0 means you are faulty, 1 means not faulty. Generally, if you see, whenever somebody, so the programmers, they are developers, they are developing software, right? That is the Pareto principle stands there, 80-20. That means 20% modules are faulty only, 80% are correct only, right? So we have to identify this 20% so that we can allot the limited testing efforts to this module set, right? So now what is your task? Now with this 1,000 modules, what you do? You train your model. You train your system by using some machine learning model. Now a new model is coming, suppose the 1001, and this model is having these informations. Now you are going to define or target whether this model is faulty or not faulty. Your system has to generate, right? Similarly, you want to grade the system. You have that historical data depending upon those information you are asking to the stakeholders, either to the teachers or the administration, right? Now a new student is coming. For that student, the informations are given. So what grade your system is going to generate? That is your task, right? So that can be done by using these machine learning models, right? Again, it came to a classification problem only. We are having some features, and by we are going to model train the model by using some learning algorithm. And you yesterday I told about what are the performance measures, right? So similarly, so the second problem, these are some of the metrics or the some of the informations you want, so that the our system will train the model by using these feature values. And when a new software or the project is coming with all these values, so how much effort is required to develop the software? So that is the main aim of these two case studies, right? So let us see the first problem, fault prone module prediction, right? And how we are going to integrate the explainable AI. Now you see we are having, this is the basic principle. Any problem you want to solve or any problem you want to automate, right? Some data source is there. So this is the name of the data related to this fault prone model prediction. So don't worry about this data set. Suppose you are having some data. Now as per your pre-processing or the data exploration part, already yesterday I told what is the machine learning process. So you do the data pre-processing, right? Then you can generate or you can construct or build a model. Now how you are doing in the model, you are dividing the data into training and testing. Then the model you are evaluating on the model, right? Now, whenever you are evaluating by using the machine learning model, as this is a binary classification or a classification problem, suppose you are interested in the accuracy, it will show the accuracy is 90%. It will not show any other information if you use the simple machine learning model, right? So, what is your target? Like that, your system, AI-based education system, which you are going to design to automate the grading system, it will grade the system. It will give the student grade as suppose B grade. But why it is giving B grade? Nowhere it is giving the explanation if you use the machine learning model. So in order to avoid that one, our task is to integrate the explainable AI to this system. So what it will do? It will provide some information. It will give that, okay, these attributes are important, right, for getting the grade A. But these values are less, that's why we are getting the B grade. Some explanation you have to give to the students so that students will understand and they will trust the output of your model, right? So this is the main requirement of the integrating the explainable AI into the system, which will understand the models. And yesterday we have, I told already, right? There are some tools and techniques for the explainable AI, which you can use to generate different types of explanations, right? So what type of explanation you can generate for the classification problem, I will say you, because if you see the automatic grading system, this is related to a multi-class classification problem. Suppose you are grading to excellent A, B, C, D, E. After that, suppose your F grade is there. Okay, P grade is there. After that, F grade. So this is a multi-class classification problem, right? So your design system is now you are solving classification problem. It is able to generate one of the grade to the students. But what type of explanation you can give to the student? That is our main objective here, right? That is the integrating the explainable AI to the system, right? So now you see, if we solve that simple problem, we are providing some input, we are applying a machine learning model, we are training the model, we are providing some test data to the trained model. So now if you see, as I told, right, precision, recall, F1 score, these are the three basic performance measures for the classification problem, right? So it is giving some numbers, right? If your accuracy 0.99, then that is the precision 1, recall 0.9. So why it is giving this value? Is there any explanation here? No. So this is the output of a basic any machine learning model you use to solve this problem, and this is the performance measure values you want. It will show only the value. So this is the confusion matrix it is showing, right? So what do we want? We want some explanation regarding the output of the machine learning model. So what type of explanation we can do? So the first explanation I am telling about, that is a partially dependency plot, PDP plot. So this is the first visualization, right? So yesterday also I told you what are the different explainable AI techniques, feature, right? Feature importance or the ranking of the features, feature attribution, and the visualization, right? So PDP is a visualization approach for the explanation. Partially dependency plot. It will show what is the impact of individual feature on the output of the machine learning model. So it will show a graph like this. So there are some Python libraries, packages are there. You can use those PDP, right? Directly you can use that PDP function uh, to give explanation to the user. Now, if you are representing this graph, suppose instead of the unique operator, because I have not done any analysis with respect to the educational data system, right? So all the case studies, right? We have done experiments related to the software, right? I'm showing the result for that. But we can map this problem to the educational system, right? Suppose the how much, right, how many hours you are spending per day in studying. That is one of the attribute we are asking to the students, right? Now the PDP plot, what it will do, it will show the sensitivity analysis with respect to the number of hours the student is spending on the reading the book. So in the x-axis, the number of hours we are varying, y-axis we are showing the output of the machine learning model. Now if you see the number of hours the student is spending, right, more hours it is spending, right, the machine learning model is able to give better prediction. Like that, the PDP or the partially dependency plot for individual feature. So because we are asking so many information to the teacher or the student, right? So due to that, your grading is like this. So this type of, or your total mark is like this. That type of information we can give, right? So this is the partially dependency plot is the first visualization technique can generate, right? Because due to the time constraints, I cannot go to the coding part because it will take again 1 hour, 2 hour for explaining the coding part. Again, if people are from different diversity backgrounds, so some of you know the coding, some of you don't know the coding. So anybody want to do this type of experiments, right, in Python, you can contact me later so that any help I can do, I will help. Okay. So this is the PDP plot, right? So in the x-axis, it is showing the feature, y-axis, it is showing the output of the machine learning model. Okay. Second one, as yesterday I have told you, local explanation you can do by using the LIME tool, and the global explanation you can do by using the SAP. So this is the LIME. This is the, whenever you will use this LIME tool for giving explanation. Now you see, suppose one particular module we are giving as a, suppose the M1001 I told, right? Up to M1 to M1000 we have used to train the model. Now the module M1001 is coming, right? So the your system, right? The model has to predict whether this module is a faulty module or this is not a faulty module. I mean defective or non-defective, right? Now if you see for that particular module, suppose your machine learning giving model is giving this type of explanation by using LIME, right? So what LIME means, your local explanation, right? Model agnostic explanation, right? So what type of explanation it is giving, you see, for that particular model, it will show the 5 important features because I have represented the number of important features equals to 5. So you can represent more features also that you can do manually. So it is showing the 5 important features for that particular module, right? So the ID value is 522. What is the value corresponding to that features? So this is coming in the right top to down. It is given in the priority order, right? So that means ID is having the highest the contributing feature. Then yellow comment. So these are one of the features of that historical data. And here, if you see, so these are the feature value. In the middle part, you see, right? What is the importance of each feature for predicting that module as defective? Because your ID value is greater than 397, because it is 522, and its importance is 0.87. Similarly, the second attribute is less than equals to 0.00, and its importance is 0.01. Third attribute is less than, value is less than 00, importance is 0.1. Similarly, you can interpret this for this D and N. So this is the explanation it is giving. This is giving what are the top features, what is the weightage of each feature, and why the model, due to this, the model is predicting this as a defective model. Right? Similarly, if you are having some data related to your educational system, you can generate the line-based explanation. But this is a local related to one instance only, one student only. It will give information, right? So if the same information two students are giving, same model your system is using, but it is able to give different explanation to the two students, students will not trust your system, right? So that you have to take care, right? So the same information provided by the two students, if they are having the same attribute values, your model, your system, AI based system is using the same machine learning model, it should provide the same explanation. So this is the explanation we are giving to the users, right? So this is the line-based explanation. So this is graphically also you can represent this local explanation because the ID value is greater than 397. This is the weightage. These values, x-axis are the weightage. Here you are representing all the attribute values, right? So this is the local explanation. Next one is, so similarly, right, for the second student, if it is giving the same information and your model is giving different explanation, that means the students, they will not trust, right? Suppose the two students, suppose the student 1 and the student 2, their internal mark, right? Internal mark 1, internal mark 2, and exam mark. Same marks they are having 30, 30, 30. This student also got 30, 30, 30. For this student, your system is giving B grade. This student, the system is giving A grade. Whether the two students will trust your system? No. Right? So if you give explanation, then only the two students can explain. Right? And this line, right? If the two informations are same, it will never, and the machine learning model is same, it will never generate different types of explanation. Right? But you change the model, right? If you change the model, the feature values or this importance may change. For the explanation, it will remain same, right? So this type of explanation you can add. Similarly, this is the local explanation you can add. That is the graphical representation, right? So now for the global explanation, I want to now in my class, instead of if you use the live, you can give explanation or your system can give explanation to the individual students, right? So in the SAP, what it will do, as this is explainable AI tool, it will give in my class, suppose my 90 students are there, 90 students it will analyze, right? And what is the importance of all the features globally, it will do that one, right? So that is the SAP value. Again, the SAP internal technical things is different. Again, that is completely dependent on the game theory, right? For that, you have to know the game theory. So what basically for the understanding purpose, right? Those who don't want to use the technical part, what you want some explanation, you can use the SAP. It will generate some SAP value. SAP value means some importance value. But it will analyze all the instances of all the students present in my class, right? So if you see, there are some values it is giving to individual features. So the feature which is having the higher sub value, that feature is important by the system for the prediction purpose, right? So the red values, right, represent these are the important values, and the blue values, these represent the more important values. So you can represent graphically also. So for all these things, these diagrams, everything you can generate from the code only. You are not drawing anything, right? For the lime and sap, you have to use that lime.explainer, sap.explainer in the Python programming. It will generate those things, right? For a particular machine learning model, it will generate. Now, if you see this ID, in the x-axis, it is giving the SAP values, that is the importance values, and the y-axis from top to bottom, depending upon the what you call that is the ranking, right? Which attribute is having the higher contribution? ID is having higher contribution. Total operand is having higher contribution. So if you give this visual explanation to the students, right? Then students can understand. Okay, this feature is having higher importance, but for this feature I have given a low value. I have the low value. That's why I'm getting a lower grade compared to that student, right? So this type of explanation we can give to the user, right? So this is a SAP plot, right? So now come to the counterfactual. So counterfactual also yesterday I told that the sensitivity analysis, how will you do? Now if you see the scenario, so this counterfactual, we are having the DICE, right? DICE. So you can use this package. You can install this one in the Python, and you can use this library to generate the counterfactual. So what is the counterfactual? Suppose you see for some one student, you are trying to develop a AI based system which is automatically grade the student. Suppose we are using here two grades, pass or fail, right? One represent pass, zero represent pass. So these are the features. So you don't right, you don't concentrate on these feature names, because these feature names it will vary from data set to data set. Now the student or the teacher has these feature values. Your developed system is generating the grade as pass grade, because one represents pass, zero represents fail. Okay, let us take reverse, because no students want to change from F to P grade, right? Every student wants to pass, right? One. So what is the representation here? Now the one represents the fail grade, zero represents the P grade. Again, this is a binary classification problem. So for these attribute values, now your AI based system is predicting that the student grade is F grade, right? Now, what is the counterfactual you have to generate to the student? Maybe the student is going to write the make-off exam, right? The student is going to repeat the course. He is going to write the backlog exam, right? It depends upon the institute policy or the rules and regulations. So, what is the target? Now, the student wants the system should generate P grade for him. So if you give some of the machine learning model by integrating the explainable AI, it will give some explanation to the user that if you change this feature value from 1.5 to this value if you change from this to this, right, then the system may predict your grade as P grade, right? So what the students will do now? The students will concentrate on this feature only, right? Suppose this is the increase. This is because this is related to your software, so values will be different. So this parameter you have to. That means suppose one parameter number of hours you are reading, right? So you are reading 2 hours only. If you read 3 hours per day, you may get the pass grade. Right? Zero. System will predict zero. So this is the counterfactual. So what is the minimal feature changes needed in the input instance so that the model flip its prediction? Now, if you see this feature value, if you will change, then the model will predict this is the zero. So the student will guess the P grade, right? So the next time he will focus on this attribute only. I mean, how many hours he is spending on the study, right? So this is the counterfactual. So this type of counterfactual also it is generating some explanation in which area the student can improve so that the model will change its prediction, right? Suppose we want to generate the counterfactual means examples. It is giving some explanations, right? So I have generated only two. You can generate more counterfactual also. So I suppose I want to instead of randomly one attribute, I want only two attributes, right? So there are suppose different 80 parameters or 80 attributes are there for the student. But the student want only what are the changes he has to do on this attribute and thus the attribute, so that again he will get the pass grade. So the counterfactual it will generate the explanation. This ID value change from this to this to this, you will get the P grade. Again, EVJ, you change from this to this, again your machine will or the model will predict this, right? So this type of explanation also they are giving to the users, right? And sometimes we want this attributes value will be changed with a pre-specified value range, right? Maybe the student cannot read beyond 5 hours. So 2 to 5 in this range, right? How many hours I have to spend so that I will get the P grade, right? So those type of counterfactual also it will generate. So how it is generating? So it is generating depending upon the historical data present in our database, right? So these are the counterfactual we can do, right? Similarly, the feature, this is not visible because this is the output I have taken from the code only. Importance of each feature contributed for generating the counterfactual also you can uh, get by using this counterfactual, right? So which features are important? What is the weightage of each feature? This also you can generate by using the lime, right? And we have generated same thing by using the dice also you can generate these things, right? Nothing. It will help to generate those things, right? Now consider the second example. So this is basically a regression problem, right? So what is the effort? How much effort is required? So previously, whatever we have discussed, this is related to your classification. Now, this is the second case study I am showing, that is the regression problem, right? So what you do now, the regression problem, I want to predict something, right? So same thing, same plots you can do. You can do the SAP summary plot. So this is a particular machine learning light gradient boost model. Now, when the x-axis, it will show all the what is the SAP value. Y-axis from top to bottom, it is showing the importance of the features, right? Similarly, if you see this attribute is more important, followed by this, and the lowest impacted attribute is PCPX. So if you give this information, student have right some getting some explanation. Okay, these features are important. These features, right, where I am having very less value, so I have to focus. I have to concentrate on those values to change my grade, right? Similarly, different models, they will give different SAP plot. If you see, this is the SAP plot I have generated for one machine learning, where the after LOC your pre-experience is given, right? But here, if you see another machine learning model, I will check, it will change the sequence also. It may change the sequence also, because the learning capability of different models are varying from each other, right? That we have seen yesterday, right? So same SAP plot you can do. You can represent the bar plot also by using the SAP toolbars. If you see this, in the Excel, you are doing the bar plot, right? What is the importance of each feature from top to bottom? It is showing depending upon the SAP value. This also you can represent. So if this plot you are generating and you are giving to the user can understand. Okay, this attribute is having the higher importance. I am having the lower value. That's why the machine learning model is predicting a very less value for me, right? So this is the bar plot. Similarly, bar plot for another machine learning model you can draw and you can check. Next is important thing is one is your explanation, that is the cohort based population heterogeneity, right? So what it will do, will divide the population's heterogeneity, or will evaluate the population's heterogeneity. So we'll divide the model's behavior across different groups, right? Now we see this diagram, you can understand because visualization. Now suppose this number of hours, this is the LOC, this is a attribute. Suppose that attribute you can replace with our student data. Suppose number of hours the student is spending for reading, right? Now if you see number of hours, it may be greater than equals to 5, it may be less than 5, because I have generated with respect to the software data set. So series is different. So greater than equal to 5 hours spending, less than 5 hours spending. Now this cohort analysis you can do. So it will divide the data into two subsets, two groups, and each group it will show the analysis. Now you can understand from this visual explanation for which group it is having the most important, for which group it is having the less important. If you see the LOC is having more important for greater than equal to 5, so for less than equals to 5. This is for greater than equal to 5, this is less than equal to 5. So those who are having less than equals to 5 hours they are reading, there this is having the more contribution towards the output. So that is the explanation you are generating, right? Okay. Then the next one is, this is one of the explanation you can generate. So for everything, your Python libraries are there for the explanation. Heat map plot, right? So in the heat map plot, for all the instances you see, all the students you are providing this information, and it will generate this function. So this function represent, for this function, what is the output of the model? For this instance, what is the output of the model? So for all the instances, for all the students, how the function is changing. So this explanation also you can generate, right? And what is the importance of all the features related to that data set, right? Okay. So similarly, one more, this is for one model. So if you change the machine learning model, the heat map also it may change, right? If you see this function, the graph of this f of x, output of machine learning model, and if you see this graph, both are different, right? So you can analyze now what is the comparison between two models also you can do, right? And waterfall plot also you can do. Waterfall plot, it will show, right? The red color represents this feature is helping the model to increase the or to give a higher prediction value. And this blue color represents, right, due to the value of this attribute, right? It is reducing the prediction value by minus 236.19, right? So you can understand this one, right? Because this LOC value is this one, that's why it is increasing this one. Because the number of hours the student is spending this much hour, So it is increasing the prediction or it is decreasing the prediction. So that is also waterfall plot also you can generate by using this explainable AI, right? Similarly, this is also for one more model. So this red color represents increase in the prediction value. Blue color represents decrease in the prediction value, right? Similarly, you can draw the decision plot. So the decision plot, if you see, this is the plot you are checking, right? So this plot for a particular instance, for a particular student, right? So what are the features provided by the student, right? And what is the feature value and what is the weightage of these features? Everything you are giving to the student, right? So for the same information, now you see the decision plot for the same model for some another student, suppose row one more student, right? For the same machine learning model, if the values are same, it should not give two different explanations, right? Otherwise, the students will not trust that model, right? Similarly, this is you, the second student is giving like this explanation, which is different from the first, right? If the values are same, it should give the same explanation by using the same model, right? So that the users or the students, they can uh, trust the output of the model. Similarly, one more scenario by using other model, you can see other model, right? So the decision is changing, right? For this student by using the FNN, by using this student, row 1, row 0 means one instance or one student, you can relate FNN, right? Okay. Similarly, you can do the counterfactual like we have done in the what do you call that is the classification problem. Now, suppose what is the total mark we want to generate? You are going to design a AI-based system which is going to generate the total mark of the student depending upon some feature values. So, for these are the feature values, right? The student is providing, and your automated system is going to predict this value, right? What is the total mark, right? Again, you can do the counterfactual, right? So what I have to change, right? What I have to change in this feature values so that instead of 7, total mark is 7 not 2, maybe out of 800, I will get in the range 650 to 750, or you can change this is the 702 to 750, you can change, right? So it will generate the counterfactual. So you change these values, you try to improve in these values. So your machine learning model, it will predict these values. Now the student will focus on these things, right? This is the counterfactual. Next, suppose this is the negative it is giving or the very less it is giving. Again, it is asking what I have to do, what features I have to change so that I will get total max 700 to 800, right? Now, if you see the total max, the machine learning model is predicting this one, but by changing the feature values, right? Similarly, the student may choose, I want to focus on these two attributes only. So though instead of focusing on all the attributes, I can focus on these attributes. That also you can do, right? Similarly, you can generate the weightage of each features by using the what you call by using the model also, right? Okay, same thing, right? It is giving 3. I want in the range 1 to 7. What are the changes I have to do? Now these are the changing value it is showing, right? So if you change these values, then only your mark will be in the range 1 to 7. Like that, these are the sum of the explanations we can generate by using the explainable AI, right? So this is minus 2.0. Now you want in the range 0 to 50. Now it is showing the generating the counterfactual. So these are the areas where you can, these are the attributes where you can do the improvement so that your total mark will be in the range 0 to 50. Instead of negative, it should be 0 to 50, right? Similarly, you can attribute, you can give weightage, right, by using different machine learning models, right? So these are some of the examples, right? I tried to relate with the education system, right? So you can see what type of data you are having if you want to develop a AI-based education system. So right, you can focus on this giving explanation to the users, right? So the coming to the feature of AI in education, right? What is the feature now? Everybody wants the AI-driven lifelong learning, right? So everybody wants the virtual mentors and the immersive learning, right? And it will help the AI in education generally. It will help the underprivileged learners, right? Those who are in right in the remote area, they are unable to come physically even if they want to learn something, right? So this AI based education system, it will reach globally for the unprivileged learners, right? So these are the some of the two references I have given. Some recent references I have given. You can see how the I think first day some sessions are taken on the generative AI, right? What is the generative AI landscape in education, right? From the student perception. So these are all the statistics, right? Done with respect to I think the China country. So you can see how the AI can be adapted, what are the opportunities, what are the challenges, right? So the some researchers they have done some statistical analysis. You can go through this paper so you can understand what is the impact of this generative AI in education. And the second step, this is the making how to make the AI accessible for STEM teachers, right? Using the explainable AI, right? So here the classroom discourse analysis, this is try to automate it. So what is the STEM teacher? Generally, the STEM teacher, this is an educator, right? Which will teach subjects related to S means science, T means technology, E means engineering, M means mathematics, right? How you will integrate the science, technology, engineering, and mathematics, right? Then only you will become a STEM teacher, right? So you can check this paper also. You may get some help, those who want to involve directly or indirectly involve in the AI based education systems, right? So this is all about this session. If you are having any queries, any questions, you can ask.
Dear participants, if you have any doubts, you can post in the chat window so that Pam can answer.
If any questions, any queries, I think there are no questions, sir.
Yes, ma'am.
Ma'am, I have a question here in the chat box, ma'am. They're
Yes.
asking to suggest any reference material for prediction of software reliability.
Yeah, you can. Those who want in this particular area, you can directly mail me. I will give references because everybody don't need that one, right? Particularly those who are interested, you please drop a mail. I will share those references, not in the chat box. You just drop a mail.
Thank you so much, ma'am, for offering to help. And as we have come to the end of this session by you, ma'am, we sincerely thank you for an enlightening session on explainable AI and the importance of local versus global explanations in machine learning models. You also explained how local explanations help interpret predictions on individual instances by identifying most features and their contributions with examples like ID values and feature weights. You emphasize the need for consistent explanations for the same input to build trust in AI systems. Ma'am, you also introduced global explanations which analyze feature importance across an entire data set, helping educators understand the overall decision making patterns of AI models. Your clear explanation of concepts like line based explanations and SAP values provided valuable insights into delivering transparent and trustworthy AI systems. Ma'am, we truly thank you for sharing your deep knowledge and the practical insights from cutting edge AI research, which will greatly assist us and all the participants in implementing effective AI solution education. Really, thank you, ma'am, for your valuable contribution to this program, ma'am. We are really honored and blessed to have you here, and we look forward for many more sessions with you, ma'am.
Thank you, sir. Some participants they are asking my mail ID, but I am unable to write in the chat box. You please share my mail ID, sir, with the
Sure, ma'am. I'll
participants.
share your
Uh-huh.
mail ID there, ma'am.
Because I am unable to write in the chat box.
I'll share, ma'am.
Okay, sir. So I will
In a
I will
moment.
share the PPTs so that you can share the PPTs with the participants.
Yes, ma'am. Please, ma'am.
Uh, okay, sir. Thank you, sir. Thank you all
Thank
the
you, ma'am.
participants. Okay. Good night.
Thank you, ma'am.